Hello, this is Dr. E. We're covering Unit 1.8 on primary productivity. Today's learning objective is to explain how solar energy is acquired and how it's transferred by living organisms. So primary productivity basics. Primary productivity is the rate at which solar energy is converted into organic compounds via photosynthesis over a unit of time. So primary productivity is all about photosynthesis, the 3 Ps. And its units are kilocalories per meter squared per year. In other words, it's the amount of energy that is used over a specific area for a specific unit of time. It's the rate of photosynthesis of all producers in an area over a given period of time. Since photosynthesis leads to growth, you can also think of primary productivity as the amount of plant growth in an area over a given period of time. High primary productivity means high plant growth, which means lots of food and shelter for very, very happy animals. Ecosystems with high primary productivity are usually more diverse, with a higher biodiversity of species than ecosystems with low primary productivity. So how do you calculate it? One thing you need to know is respiration loss, RL. Plants use up some of the energy they generate by photosynthesis, by doing cellular respiration. In other words, they have to live themselves. They have to move, they have to reproduce, they have to grow. They have to transport things throughout their body, just like we do. Think of respiratory loss as the taxes plant pays on its paycheck. Gross primary productivity is the total amount of sun energy or light that plants capture and convert into energy or glucose through photosynthesis. Think of gross primary productivity as the total paycheck the plant earns via the sun. Net primary productivity is the amount of energy or biomass left over for consumers after plants have used some of their for respiration. So think of net primary productivity as the actual amount the plant's paycheck it keeps after taxes. MPP equals GPP minus respiratory loss. Gross minus loss equals net. And here we just see it in a picture where the total photosynthesis coming in, what is captured by the plant is gross, energy used is lost as heat and for growth, energy left over is what the plant does. So ecological efficiency. You can see here the sun comes down, 99% is lost. 1% actually goes to photosynthesis. 60% is lost to respiration, which leaves us about 40%, or 0.4%. So a portion of incoming solar energy that is captured by plants and converted biomass is net primary productivity or food available for consumers. Write that. Generally, only 1% of all incoming sunlight is captured and converted into gross primary productivity by photosynthesis. Of that 1%, only 40% of that 1%, or 0.4% of the incoming solar energy, is converted into biomass for plant growth. Some ecosystems are more efficient than others, meaning they have a higher net primary productivity than others. So let's look at that. The more productive a plant biome is, the wider or higher biodiversity exists in that biome. Try to predict the most and the least productive terrestrial and aquatic biomes. Let's think about that for a second. Okay. So if we look at that, the water availability, temperature, nutrient availability are all factors that lead to high net primary productivity. So swamps, marshes, tropical forests have lots of water, they have lots of nutrients, they have a high temperature. Coral reefs and salt marshes generally have moderate to high temperatures, so much nutrients it's not funny, and they're also fairly close to the surface. Shortage of any of these three will lead to a decreased net primary productivity. Deserts have low water and nutrients, and therefore it takes a long time for them to recover from a disturbance, like someone riding their motorcycle out in the middle of it. Tundra has low temperature and liquid water, and therefore it takes a long time for organisms to grow. Plus it has permafrost, which kind of puts a damper on it. Open oceans, open oceans? They have no nutrients because there's not a lot there. However, overall, of all the oceans, it has the most productivity overall, but it covers 70% of the Earth. So, even though it's a tiny bit per square meter, overall, it's quite a bit. So, practice FRQ 1.8. Can you describe the process of net primary productivity? And 2, can you describe the relationship between primary productivity and biodiversity? Thank you, and I hope that was helpful.